Hey, Sean, how's it going?
Excellent, Peter. Another episode of three engineers, two engineers,
Two engineers, three
three opinions.
opinions.
Yes.
Today we're talking about some windows. Not the glass, but the framing, how the windows are attached to the building, what's holding the glass, et cetera, et cetera. So,
Yeah, I
yeah.
mean the windows is the glass, but really we're kind of talking about we talked about glass in a different episode of this.
Yeah.
So we're talking about today is the frame more than anything,
Yeah.
a bit of the hardware.
Yeah. We might dip into glass a little bit, but it's mostly the hardware and the
But
frames.
do you think that windows have always had frames? Do you think there's a time where people just put glass into walls?
I think there was a time where they didn't even put glass and they just had holes in the walls to be able to see out
That's
of.
true. Yeah.
Like old castles or whatever, they'd have like those really narrow, wide on the inside but narrow on the outside, more for protection and being able to view out without people like shooting an arrow in or something like that.
And then someone decided it was cold and drafty.
Yeah.
Let's invent glass first of all.
Yeah, first invent glass. That's the first thing. Maybe I wonder if lightning invented glass and someone just like was on a beach and they're like, wow, this clear thing after the lightning hit the ground.
Yeah, it's a tough one.
Yeah.
Figure out how you invent that.
Yeah, we probably have to get someone offline to correct us on this. But if you know how glass was invented, please leave a comment and we'll discuss.
Maybe you had a big fire and you're cooking something, and afterwards on the ground was this like hard rock.
Sure. Might have to have some like wind or something like that to blast furnace it a bit. I'm not sure how hot it has to be to melt the silica.
It's all great.
Anyways,
questions, yeah.
all the good questions. But that being said, yeah. So it probably started with castles having those like little just gaps in the walls, or
Yeah.
having a cave with one side open. And then once we had glass, once that was invented, I'd say the first ones probably didn't have like a pre-manufactured frame of some sort. It would probably just be glass and some strips of wood to kind of hold it in there, probably.
Yeah.
Yeah.
So would you say that Windows is the first off-site modular component? It'd have to be
Wow.
up there, right? Have to be
Wow,
up
that's
there.
a big, yeah. No, I haven't even thought of it that way before, but yeah, no, definitely.
Oh, maybe brick before that.
Except the brick is like an individual building block that you still have to build on site, whereas the window comes in prefabbed into the opening and you kind of just
Yeah.
seal it into place. Depends on where you draw the line at prefab, I guess.
Well, this has been my comment about prefab. I was like, well, we already prefab windows.
Sure. Why not just do the whole wall around that window?
Yeah.
Interesting. Very, very good point.
But if you're gonna prefab the whole wall, then why do you need a frame in the first place? Can you just put the
Just
glass
use glass
into the wall?
and just jam it in. Yeah, no, yeah. We're getting into, I guess, cutting edge or a little bit more
I
kind
got some
of
ideas.
Yeah, I got some ideas.
from that.
And the thing is, like, anything in the world is possible as long as you look at the basic design principles. And, the first principle is to make sure it all works. It's going to be strong enough. It's going to be weather tight enough. It's going to be, fire resistant or whatever it might be, whatever criteria you have.
Well, the windows have standards. Maybe we'll start with talking about some of those.
Sure. Okay, which standard are we talking first?
Let's start with maybe New Zealand.
Like testing standards?
Yeah, well, Windows have multiple standards, I
They do.
suppose.
They do. And a lot of people kind of know some of the numbers or some of the titles, but don't necessarily know where the scope of those are. I'd say for me, the most critical ones, or the ones that I see most often, are NZS 4211, NZS 4284, and probably NZS 4223 for the IGUs.
Yeah, that's
I'd
probably
say.
good. Yeah.
Probably those three.
Yeah.
There's other ones, the Wagon Standard, there's E2S one that has some details and stuff, but
Yeah, 4211 recently updated
Cool.
in 2022.
Cool.
I was fortunate enough to be on that committee and helped kind of steer that into what the new version looks like. And
any major changes?
probably the biggest one would be the introduction of a mid-rise window standard.
Oh,
So previously, the window standard was always focused around low-rise and ends at 3604 wind zones.
sure. Smaller residential stuff.
Yeah, and then there was a sort of there's been this move or this desire from MB to have sort of more off-the-shelf solutions for mid-rise space.
Okay, sure.
So we have EM7, which is your cladding test,
Okay.
up to 25 meters, and now we have in 4211 we now have a window standard up to 25 meters, which incorporates some seismic racking.
Oh,
The idea is you take your cladding test, your EM7 test, match
Sure.
it with your 4211
Sure.
EM7 window, and
Sure.
you match those together, and you've got a solution.
interesting.
Trying to put us out of business as quickly as possible, which is welcome news.
Yeah.
Some of the stuff we get involved in is really unnecessary for us to be involved in. So.
Yeah. A lot of the stuff we do is like writing reports for stuff that everyone kind of just generally already knows.
A lot of it is, yeah.
Yeah, so ideally off the shelf would be better. But like you mentioned that they've added, this, I guess, modularity to it. So you have your wall test, you have
Yep.
your window test, put them
Yep.
together. What's the difference between that and a 4284 test, which I thought was for cladding and window all together? Is it the separation of those two kind of thing? That's the difference?
So 4284 is a test of a facade system,
Okay.
and your specimen is the cladding of the window and all of the parts that go into
The
it.
junction between those two.
Yeah.
Sure.
Now, people have sort of been using those interchangeably to mean that the cladding itself is different from the window,
Sure.
but really 4284 is the whole system combined and the details and
This
the
type
window.
of window, this type of cladding,
Yes,
altogether, that's the
yes,
system.
yes.
Sure.
With now we have a system where EM7 has your detail, and now you can kind of swap and chop and change any window and put it in there. So
Interesting. And just to kind of bring it back, just in case there's anyone who's listening online that hasn't dealt with any of these tests before, basically the general concept is in a lab, you build a wall sample or a window sample, you spray some water at it, you spray some air at it, and then basically test it for structural capability, movement, and water tightness.
yeah, calibrated water, calibrated air.
Sure, of course. It's not just any water, any
Yeah,
air.
yeah.
A certain amount.
Yeah, tightly controlled. But the idea is with the test procedures, you've got repeatability. You can compare one sample to another in an informed way. It's not to say that windows are ever going to see those sort of forces in service.
Sure.
It's just it's the same. It's repeatable, and we can do it the same for each sample that we test. So.
Sure, sure. It's an easy
But
comparison.
yeah, more or less, you're applying water on the outside. You're trying to suck it through the sample with a really big vacuum, really
Sure.
big expensive vacuum.
Sure. Calibrated, obviously.
Which
Everything's
is
calibrated.
sort of the what's happening when the wind pressures are hitting your windows. Is you're creating forces pushing water through the window.
Sure. Going through capillary action areas and testing those pressure equalization kind of
Yeah.
pockets and things like that.
Now, some would. Here's an interesting. If anyone is listening and knows the answer to this or done research, there is an argument being made that air positive pressure from the outside is different than negative pressure from the inside. And at first, I was pretty skeptical,
Same.
but I think in certain systems there may actually be some legs to that argument. So
I'd say it depends on probably gaskets and whether they're being pushed against something or they're being sucked off of something. If that makes any sense.
no, I'm thinking the pressure difference would be the same across gaskets, but it's some of the channels and air gaps in channels and how they're pressurized versus not pressurized.
Which direction does the airflow go? Would matter
Yeah,
in
and sort
that
of if you have
scenario.
like 3 chambers in a row and this one's pressurized and this wide, not like. If anyone's done some research on that, I'd be really curious to know.
Yeah. I'd say
Physics sort of says they're the same, but people have told me they're different. Well, people have speculated they're different, mostly because they've failed the water test on the site,
I was about to say that.
and they're
Yeah.
trying to give us reasons why their system sucks. And
Yeah. I can see if we're actually doing a test and we're really getting down to the first principles of it, yes, there's probably certain scenarios where positive pressure versus negative pressure, there might be a difference. But like you said, it's only once you're on site, done 3 or 4 tests and the window still doesn't pass. That's usually when this explanation comes up.
plausible hypothesis is what it is.
Sure.
Yet to be proven.
Yeah.
But
Yet to be proven either way, like
Yes.
right or incorrect. So, yeah. Interesting.
but the testing is a really important part of the design and manufacturing process in that it proves your system could work,
Yeah.
more or less.
Yeah.
And then so you can, based on how difficult the test you select for it, sort of gives you the range of exposure you could use on your building on the outside. So you want to pick a window that's done at least as much wind pressure as you might expect to see in that building.
Sure. And when we're doing these designs, we're usually looking at the KPA pressure value as opposed to high, extra high, very high, those kind of subcategories.
Yeah.
Because it's better to just look at the actual number and compare.
Yeah, so to give you some perspective, 455 pascals is the extra high wind
Yeah.
zone for water penetration.
Yep.
And that's good for a lot of buildings that most buildings
Most
that are built.
mid-rise.
Most rise, yeah.
Yeah.
But you can also get windows up into I think the top one in the NAF standard in North America is 700
Pascals.
pascals,
Sure. That's
and even
pretty
higher
high.
than that. Yeah.
Yeah. I've seen some that are like hurricane force wind kind of resistance.
It has a higher water penetration requirement than anywhere else, though.
Do they?
Yeah, twice as
Interesting.
high.
Twice as high?
Yeah.
It's usually only 10% of the SLS as opposed to 20?
15% in the NAF
15 instead of 30. I see.
30% here.
Interesting.
And
If you want to discuss more about that, let us know. The actual test standard comparisons.
There was definitely some discussion with the last iteration of 4201 about reducing that. And the general consensus was it's not broke, don't fix it. And
the only time that I find that it's quote unquote broke is once we're testing on site, a window has failed multiple times. That's usually when someone will point at the test pressure. And so the key thing is to decide on the test pressure before the test, make sure we're all on the same page and that we're not going to waffle back and forth.
Back to the original writers of the original standard, back to like the 80s, 70s, whatever. And how did you pick 0.3? And they're like, man, it seemed to work. It's like
seemed about right.
It seemed to work, and it's been working ever since. So,
I mean, to be honest, like if you've never done a deep dive into the building code, a lot of it is just like that. It's rules of thumb based on experience, and 30% was probably about right. We tried at 10%, it wasn't quite enough. Like it's all little bits and bobs like
I think
that.
everyone's afraid to reduce it by anything because what they've got works.
Yeah.
Here's part of the discussion point on how much water, how much air pressure in testing is the right number.
Sure.
If you imagine 100 kPa, 100 pascals, is about 10 millimeters of water. With that much water, it's 100 pascals.
If you put this water into a straw and then suck from one end kind of thing, or
or if you were in a submarine and you went below the surface by 10 millimeters.
Understood. Got it. It's just the pressure. Got it.
So going from 0 at surface level to 10 below is the biggest jump in performance expectations you'd get.
Sure.
As you go down to 20 mils or 200 pascals, you keep gaining in that pressure.
It's a kind of a curve, I guess.
Yeah, you sort of get some diminishing returns in terms of performance. So that first, just passing any test is probably better than nothing.
Sure.
How that translates to on-site testing is a totally different discussion. But
Sure. I mentioned that in my my kind of deep dive into Windows. But yeah, there's a difference between lab tests and site tests, and you're testing different things. With a lab test, you're testing the general pressures that it could theoretically reach in a perfect install condition, whereas on site, you're more checking that it's been installed and manufactured properly. As opposed to like the design of it, it's just making sure that it's going to perform as designed. Two kind of different things, or am I misunderstanding?
Yeah, no, I think you're on the right track there. It's a good way to classify them.
Sure.
The reason those are different and the reason the site testing is important is probably worth spending some time on. When you're in a lab setting, you can try as many times as you want to get your window to pass.
Sure.
You could try hundreds of times.
Fix this thing, fix that thing, put a piece of tape here, put a piece of sealant there.
Yeah. Now, all of those things do get recorded in the test report.
Sure.
But a lot of those little things that it took to get it to pass don't necessarily get translated over to the person actually building the window for your job site. They don't know that you had to install sealant in such a way, or you had to cut this gasket in a certain spot, or we drilled actually extra holes over here, or all of those little nuances that it took on attempt number 8, 9, 10, 11, 12 to get your sample to pass.
In the lab.
You don't necessarily know which one of those things was important.
Sure.
Or how do you communicate those little things in very complex 3D dimensions to someone who's hasn't seen the test, hasn't seen their test report.
Sure.
We have seen in New Zealand some of those modifications that happen in the lab not getting translated properly.
I would go even further than that. I've had certain projects where we have specified a system based on a test report, like a lab test report. And then once it gets installed on site, they've installed maybe not a completely different window, but the gaskets are different, the drainage holes are different, the heights are different, because internally they've passed a test at a certain level, but then they have different levels of manufacturing or components to hit different pressures or things like that.
So that's translating that lab performance to. So they would have set up their sample, done some tests, got to 350, and say, right, that's what we do for this.
Correct.
And let's fix that thing. Okay, you do those two things to get to the next level, and then to the next level.
but I was never told about that. It
No.
wasn't specifically laid out in the test reports in any sort of easy way to understand. It only showed the final test that was done,
Yeah.
all the modifications, and we assume that if we're specifying this, all the modifications are going to be copied on site. Obviously, that wasn't done. And then once the window failed a few times,
Yeah.
and they start to go remanufacture and refix things, they mentioned to us, oh, we added this thing, we added that thing, we added that thing.
Yeah.
And my question was, why was that already not there?
All best intentions, by the way.
Sure,
Nothing.
absolutely.
These are not nefarious actions.
No,
These are.
it's a misunderstanding. It's
yeah.
I assumed one thing, they assumed another thing,
Yeah.
and then we both met in the middle at something that didn't
Yeah, and
satisfy both of us.
if you're not doing the site testing as your QA to make sure that what's being built actually matches,
Sure.
then
Leak later on down the track, and
Yeah.
people have to be brought back to site 3 years later, 4 years later.
long story short, your lab testing is essentially useless.
I mean, for me, the only use it has is for code compliance in a compliance report, personally, and to compare this suite versus this suite in terms of what pressures they can generally reach. But without having a site test, it's all null and void. It doesn't necessarily mean anything.
Yeah, so it's sort of like, remember the Volkswagen particulate matter thing years ago?
I owned one of those
Oh,
cars.
did you own one
I
of
had
those?
a
Yeah.
diesel Jetta,
Yeah.
and they lied about the well, not lied.
They
It
had a
like a setting.
software,
Yeah.
a software loop that was like,
Yeah.
you're being checked.
Yeah, you're being checked. Substantially reduce power. Make this not a car anymore, and then it'll pass, and then it goes right back up. So yeah,
Yeah, some of that on site. If somebody knows that window's gonna be tested, they're gonna do a little extra to.
which is another reason why I try not to tell anyone which windows I'm testing.
Well, it defeats the purpose.
Yeah, rock up on site, test a random one.
We're on the side of the window, like we're all in the same. We would want windows to pass.
Of course, yes. To be very clear,
Yeah. But we also want a representative sample of the windows.
Correct.
You don't want a doctored sample. You don't want a Volkswagen issue.
Correct. And I think the other key is that it helps everyone. It helps the client, it helps the eventual occupants, it helps the contractor, it helps the window installer, because you find the problems while everyone's on site doing construction, as opposed to doing it 3 years later, moving people out and fixing things, replacing windows, whatever it might be. So
At least the EPA does in the
US.
in the U.S. I'm sure they do in other jurisdictions as well. They'll randomly buy cars off the lot from manufacturers and test them to see if they get the fuel efficiency
That
that they
is,
think they did.
I feel like that makes a lot of sense. Why not? Yeah.
So it's, this came up. They were talking about oil
Okay.
and breaking in an engine. They used to put in break-in oil.
Oh, a
Which
separate
is
type of oil.
this is like the 70s, 80s, 90s. They
Interesting.
put a separate oil in, which would because when you're breaking in an engine, you have tolerances that you're wearing down.
Sure.
And so that first oil you want to be a bit different than that oil.
To collect all of those, I guess, shavings and things like that would be coming
Yeah,
off
it was
there,
different
maybe?
viscosity, different whatever.
Sure.
To sort of anyway, there's a break-in period after 5,000 kilometers kind of
Yeah.
thing. Then you switch oils to your operating one.
Yeah.
But they were getting caught because they weren't providing the right oil. So
And the oil would affect
EPA was
the-
catching them and saying, this isn't per your manufacturer's specs. You're doing something, you're doctoring this, and you're not getting the performance that you said you were going to get.
Because it's at the break-in period. Yeah, I see. Interesting.
So now all of the manufacturers don't use break-in oil anymore.
Interesting.
Yes.
I wonder if that is affecting durability of cars long term.
We're
We're getting into the weeds about
No,
cars.
but it goes,
yeah.
it goes to the
Yeah,
point of if
yeah,
you don't check what's actually been delivered, you're probably not getting what you expected.
Yeah. A fun segue. I just kind of got a little idea in my head. Cars can kind of almost be, compared to houses in terms of you have to separate the inside from the outside. There's water at very high speed, air trying to push that water inside.
Yep.
But all the concepts are generally the same. You have gaskets that close and seal. You have pressure equalization channels. You have drain channels and things like that.
Actually, fun exercise for everyone listening at home is when you go into your car next time, look at how they've done the gaskets on the seal of the door.
Sure.
There are two gaskets.
Yep.
An outside seal and an inside seal.
Why is that?
So
Are you saying one seal's not enough?
Well, one could be enough.
Could be enough.
If it was perfect.
Yes.
But it's not going to be perfect.
Nothing's ever perfect. Ever.
So it's not going to be perfect. So we've got two seals. Even if both seals were perfect, that still wouldn't work.
Sure.
The outside one needs to be a bit leaky.
Sure.
It needs to be just deflect water, and you'll notice the outside one drains the bottom, and the inside one is continuous and seals. So that's rain screen principle. Inside is an air seal.
Yep.
Outside one is a rain screen shedding the surface. So if you're ever confused about what to look for on window gaskets, there's a handy reference.
Yeah. And I think that's just that's the key way to design any window, in that there is an external seal or deflection layer, an internal air seal, and drainage pathways. That's just generally how it has to work. You reduce the amount of water going into the system, and then you drain it out when it comes out.
If you have two airtight, this is another trick. If you're having trouble getting an operable vent to drain, to not leak,
Yeah.
and you've got two continuous gaskets,
Yeah.
the reason that doesn't work is you don't get pressure equalization across the outside one. The gap between layers needs to pressure equalize across that gap so the water can't jump it, which is why the outside one, if you actually cut holes in it, will actually work better than if it's continuous.
Yep.
Otherwise, your pressure jump across those will all be equal.
Yep.
It'll act as one gasket essentially.
Yeah, like I had a project recently where we were talking about cladding. It's not windows, but the concept is essentially the same. They had this cladding that had like a tongue and groove kind of situation, with fairly close tolerances, like things are touching each other. And they had done some testing just in-house with the hose just kind of spraying, and second they put some water on it, blasts right through. Whereas what I was doing was comparing it against like a timber weatherboard cladding, and there are certain design guides from brands and in the standards showing that with a timber weatherboard, you'll have your overlap, but where those boards overlap, there's kind of like a little groove that gets machined out, and that's your pressure equalization.
Yeah.
This cladding that they were talking about didn't have that pressure equalization gap, and they were asking me, should we make the tolerances even tighter so that it really squeezes shut? And I said, that's probably going to do the opposite of what you want. Because,
hard.
yeah, there's like, you can make it nice and tight, but it has to be 100% perfect to work, and nothing's 100% perfect. So basically suggested to put a little bit of pressure like equalization and just make a big gap so that you have a seal on this side, it's open on that side, so you have that drainage pathway.
Yeah. In Windows in
yeah.
particular, I can't remember who just told me this. Oh, I think it was Brian. He said, somebody knows what they're doing when they come to a window test with a drill, not a sealant gun.
Yes. Yes.
If
That is a very good point.
If you know where to drill the holes to get things to equalize,
Yes.
you'll have a much better chance than trying to solve that leak with a sealant gun.
Yep. It's the same reason why we recommend cavity claddings and rain screen claddings as opposed to a face sealed cladding, because that seal is never perfect and you'll always have leakages through it. So you might as well just assume that the leakages are there and design around them. And yeah, like you said, usually adding extra air pathways and drainage pathways is the key, not sealing up more.
Yeah, it can be really interesting when you're trying to troubleshoot a window in terms of where you want pressure to equalize and how that flows.
Yeah.
Testing a large building in an Auckland building, a 17-story building called the International, if you want to look it up.
Sure.
It's 17 stories of all sliding doors. It's all triple leaf sliding doors around the whole perimeter. A beautiful building, very expensive building.
Sure.
And so these were bespoke sliding doors for the specific project. And we're having some trouble in the testing facility in China getting this sliding door seals to basically work.
Sure.
And we drill holes, add sealant, drill holes, add sealant. We're having trouble getting it to work. And what we ended up doing was a cover cap only had one gasket, not two. So in the channel,
the cover cap over the track of the slider?
over the track. So essentially we had a path from inside to outside where there's only one layer of defense where the water could get to the air seal.
Right. I see.
So we ended up adding a secondary air seal.
Okay. So that solved it all.
Yep.
Easy. Interesting.
The water was contained inside the window in stuff that's not going to cause problems, but you can't see it from the inside, which was the...
Sure. If you've never seen a test, if you've never seen water, like sliding doors being tested or anything like that, the way that they generally work is you have your track and it is deep enough that as water starts to leak in, it doesn't overflow that track and is able to drain out the drain holes.
math on you can go to your sliding door at home. If
Yeah.
somebody's got a sliding door in your house, you can measure the depth of the channel that you see, and that is basically what your sliding door is rated for in terms of pressure.
Yeah. There's a pretty linear correlation between those.
Yeah.
Which is kind of interesting. But yeah, adding extra heights, adding extra overlaps kind of helps. But cool. Let's shift gears here and talk about the different types of windows, different framings and stuff like that. I talked about it in my deep dive, but let's talk a little bit more about how we feel about them. Do you have any specific types of windows that you like best?
Agnostic.
Okay.
We just need to recognize the pros and cons and limitations of all these materials. 'Cause
Sure.
they're all have really good things, really bad things.
Sure.
So at one end of the spectrum, you've got, I think wood actually is an underappreciated material for
Yeah. Timber
specifically
windows are great.
for low rise buildings.
Yeah.
Really thermally efficient.
Yeah. They look pretty.
Look pretty. Yeah, they've got a sense you can touch them and that kind of stuff. They've
Yeah.
got some old like nostalgia to them.
Yeah. Can sometimes have-
Horrendous durability though. Horrendous durability.
So yes,
Relatively,
in comparison
worst-
to aluminium or UPVC.
the worst material you could choose for durability.
Generally, if there's some ones that put like an aluminium kind of cap over the outside, which helps.
There are ways to do it correctly.
Yeah.
Yeah.
But you're starting with a material that is less durable than the rest of them.
Yeah.
And so you have to make them work essentially.
So I worked on the Pike Place Market in Seattle.
Sure.
Sorry, not the Pike Place Market. The Starbucks Roastery in Seattle.
Okay.
In on Pike Street.
Sure.
It's like their showcase roastery for Starbucks.
Okay.
Really cool facility. Open late night, early mornings. If you ever in Seattle need something to do, it's probably 10 blocks from Pike Place kind of thing.
Cool.
But it's a historic building that was retrofit and needed to use wood windows.
Sure.
So from a durability perspective, we've got some sort of problems, but the simple solution to increase the durability was membrane coating in the glazing pocket. The spot where water can get, where the glass sits. We didn't want water sitting underneath that and just rotting through the sills. So we added an extra layer of paint,
Okay.
thick paint, into that spot.
Cool.
Which gave it a lot more durability.
Cool.
You're talking about like might get 15 years of life from a standard timber,
Without maintenance.
whereas this you'd probably get into like the 30 range. Where
I'm surprised that they wouldn't have just already had a coating in there or a membrane in there in that pocket.
these were retrofit windows to look like historic
I
windows.
see. Okay, so kind of bespoke.
Yeah.
Gotcha.
Yeah.
Interesting.
Yeah.
Yeah, so timber, I like them. They definitely work. I generally probably wouldn't choose them for my building just because they do cost a lot in comparison to the other options. But for especially like a historical building that has to have timber look to it, or if you just prefer timber, then that's probably the best one to go with.
Yeah, another project in Seattle I was involved with was Queen Anne High School, and that was retrofitting all of these historic windows.
Sure.
Shout out to Legacy Construction, awesome job on historic windows in Seattle area, Tacoma.
Sure.
They've done some wonderful stuff with timber windows. And
The historical ones are they tend to be difficult. The ones that I've dealt with a lot are like steel framed windows on like older university buildings, on older when they used to build factories that actually looked pretty on the outside and they had like those big beautiful windows with really thin framing.
Yeah.
So I've had those, and some of the projects went with like a secondary window on the inside. So you just leave the external
Storm
in place, basically, kind of fix up, paint, reseal the outside, and then put a storm window on the inside. But there are increasingly newer profiles that you can get to replace those old ones. So you could have a steel window that still has that same thin profile, but has a thermal break in it. There's also aluminium ones that are thermally broken, but are very narrow. I think there are imported ones from Europe. I know Neufer and Rayners have options that are very thin.
Yep.
So yeah, it's cool to see that there are newer products with higher efficiency that are still looking like the old one, because that's usually the criteria that we have to match when we're doing a retrofit.
Yeah, when people see steel windows, they think about the thermal bridge, but actually much better than aluminium.
Oh, like
20 times better?
like a crazy amount. Like aluminium is so bad at thermal bridging. Sorry, so good at thermal bridging. So bad at being an insulator.
It's the best.
On this, or just regular steel, already you're kind of nearing the thermally broken aluminium range.
Yeah.
Just like that. Or at least the the New Zealand thermally broken, which has like little baby thermal brakes. You can see it's just that one little piece right
You gotta
there.
start somewhere.
Yeah, whereas like North American frames tend to have a much larger thermal brake. You can see it right there with lots of, zigzags and whatnot. But yeah, I think steel is a good option. What I find I care more about than material is the hardware and is the operability of it.
That's what gives it the quality, right?
Yeah,
It feels the feel of quality.
it feels different.
Hardware is it's true. It's like when you a luxury car, that the sound when you close the door.
It feels different.
There's engineers that engineer the sound of that.
I feel like there's one car that I read about where they had to specifically tune it because they wanted a nice, light, easy to open door, but also wanted it to sound that way. And usually those two things don't correlate.
Sounds like a Tesla move.
Yeah, maybe, could be. Most people are used to, here in New Zealand, is like an awning window with one of those little handles at the bottom that has like that little plastic flap. That,
Cam handles.
yeah, like a little plastic flap that usually breaks off so that you can either open it and lock it slightly open as a vent or fully closed. But that only locks in that one area. Whereas I got some new UPVC windows that are tilt and turns, like European style. And you have this one handle that has 1, 2, 3 locking places, and it sucks closed on the gasket.
At least, yeah.
It works a lot better. Any other hardware stuff that you've kind of seen that really stood out?
The tilt and turn stuff's really nice.
Yeah.
I mean, you're gonna pay a premium for it for sure. But
With the UPVC, not. Like, I paid
okay.
about the same for a thermally broken aluminium for my house.
Okay.
Yeah, they're cutting down in price pretty well.
Definitely see a difference in roller hardware. When you get the right roller hardware
Like on a slider, you mean?
on a sliding door.
Sure.
Yeah, that could be a gigantic difference in how hard it is to open.
Because
And how it wears as well.
typically with sliding doors, it'll be brush gaskets. And so you have a brush gasket all the way along the track, brush gasket between two interlockers and one at the top. And yeah, like the door feels heavy and you're kind of like really, you can hear the brushes brushing, whereas
The brush is brushing, but also the stuff you can't see underneath. You can get all sorts of quality of the actual roller bearings and
brass or aluminium or stainless or plastic or
yeah, but also everything in the range from like high end Ferrari type rollers
Sure.
down to that. We've got a project right now where we're retrofitting motorized rollers because
Sure.
the doors are so heavy
Sure.
that you couldn't move them otherwise.
Yeah, like once you get to a really big door, you have such a thick piece of glass to have that span. Those doors get pretty heavy pretty quickly.
Yeah, so that project in China that we were testing was triple sliding doors, and while we were there, something we hadn't considered was the operable force, and the standards all have some sort of minimum or maximum amount of force required.
Yeah.
So local market in China in Shenzhen and found a fish scale, a luggage scale.
And just like pulled on it.
Yeah,
That's fair.
luggage scale.
How many newtons or how many kilograms?
Yep.
But I find we have some samples in the back, like on our little test booth, or not a test booth, our little mock-up.
Yep.
The sliding door that we have there is one of the. It's not a lift and slide, but it's a. What do they call them when they squeeze outwards to seal on the gaskets? They have
I
a
don't know what
different
they're
word
called.
for it.
Yeah,
Maybe
maybe.
squeeze
Yeah,
and
something
slide.
like
I don't know.
that. Squeeze
Whatever,
and slide.
whatever it is.
Slip and slide.
Yeah, slip and slide. But what it is like once you open the handle, the door kind of pulls backwards from the gaskets, and so there's nothing rubbing anymore when you're actually rolling it along.
Yeah.
And so if you just kind of push the door a little bit, it'll just keep rolling. It won't just stop. Whereas that's not typical for a sliding door usually.
Yeah, you want that gasket compression to really get good seal. So anytime you've got like a sliding connection, you're not gonna get a good seal. So like
Yeah.
they think about like sealing a pickle jar or a mason jar, that screw action gives you compression on the top. Whereas if you had like a Ziploc bag or something, you're just not gonna be able to get the same sort of compression.
Yeah. The sliders, especially when you have brush gaskets, it's literally just like a hairy brush that rubs against the thing. So air can still definitely come through that. Which is why you have to worry about the heights of your track to make sure that water doesn't fill up too much. And also where the door kind of clamps over the track, that's usually where the water comes in a water test. Whereas if you have a gasket, all of that gets sealed at the outside, so it really reduces the amount of water that comes in. And like I really like UPVC windows just because I find that they're a good kind of balance between cost, hardware, quality energy efficiency, sound deadening, blah, 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 blah. Do you find people are trusting of the UPVC or generally less trusting of the PVC? Because I feel more the latter. People distrust the UPVC.
New Zealand's a very funny market. If you are in Europe or North America, you'd be shocked to know that PVC in the New Zealand context is 5 to 10% of the market at the tops, whereas the rest of the world's probably the reverse.
Also, here they're priced about the same as thermally broken aluminium, but in North America, usually it's the cheapest option by far.
Yeah, yeah. So it's a really interesting market that way. I think everywhere had the same problems with UV stability. It's not just New Zealand that had the problem. Everywhere had that problem.
Sure.
But New Zealand hasn't seemed to have caught up with the technology that's changed. Show on Netflix, White Gold.
I did. I feel like I saw a few episodes and then kind of fell off.
Yeah, it didn't go anywhere fast. But,
Yeah.
but it was all about that.
It was all about, the 80s and selling that, that plasticized PVC
Yeah.
without any sort of sunscreen on it that would turn brown and kind of crack in the sun.
If you know what happens at the end of that series, put it in the comments below. I'm pretty sure I know where it goes.
Spoiler alert.
Spoiler alert! I haven't watched the series in totality, but as I was watching it, I'm like, oh, I know where this goes.
They're going to get sued, aren't they?
They're gonna get sued. Yeah.
Of course.
Yes.
But I think a lot of people here in New Zealand still have that kind of judgment or that prejudice against the UPVC or PVC in general, that it will turn brown, it will start to crack in the sun, the UV here is pretty high, et cetera, et cetera. But it's different. It's unplasticized, which is a big key part. It's got titanium oxide in it. Sometimes they have coatings on them. They work pretty well and they last a long time. And
Yeah. The awareness on that failure mode's pretty well known now.
yeah, it's been sorted. But yeah, I like the UPVC. I like the tilt and turn if I'm choosing my own thing. I mean, that's what I bought for my house. But I really like the tilt and turn because of the fact that you can lock it slightly open for some ventilation if you want, some airflow.
Call me old fashioned, but it's like a good old fashioned awning, to be honest.
An awning window?
Yeah.
I mean, fair. I find that the tilt and turn works for me because I live in an apartment and I can't access the outside of my windows to clean them.
Sure.
And they very rarely do window cleaning.
Yeah, sure.
So I can open them up, give them a quick wipe, and then close back up. To me, it makes sense. But yeah, no, awning makes sense. It's all outside. It kind of falls off of it. I get it.
Yeah.
Yeah.
I've got sliding windows in my Canadian house.
Okay. Sideways sliding.
Yeah,
Okay.
sideways sliding.
I see. Fun.
Yeah. They've
Classic.
Been in there since I was 5 years old. So.
Sure. My old apartment in Toronto had sliders as well.
Yeah.
Pretty standard.
Yeah, so we're recording this about a month before I moved to Canada, and I'm moving into my childhood house.
Fun.
Which was built when I was about 5 years old. So
Is it
kinda
all
cool.
good to go, or do you have ideas of what
it's
you need
all
to
the
retrofit?
original 1990 single family house.
Is that good enough for you?
It's gonna have to be to start with.
Fair.
To
Okay,
start
cool.
with, yeah,
Sure.
yeah.
But maybe eventually have plans to upgrade things?
Yeah, it'd be interesting because I think one of the things we always talk and preach about these upgrades and let's upgrade our house to a passive house.
Sure.
And you're like, it's gonna cost how much? There's some realities.
Yep.
Some realities involved.
And I mean, same with me. When I first moved into my apartment, I did I did a SketchUp model. I plugged it into PHPP. I ran the numbers. As it was not super efficient. Replacing windows, putting ventilation, increasing air tightness. Got it to passive house, although I didn't plug in all of the thermal bridges and things like that. So obviously not going to be certified. What I found is that, it was fun taking my recommendations and putting them into practice in my own place.
Yeah.
And trying to schedule it out and plan it out such that I do the windows and the ventilation now, and then eventually I can do other upgrades. It's been kind of fun to put that kind of in order. And it's also been fun to talk to my neighbors in the apartment that see my windows and they're like, ooh, new windows. Can I get these? And so I'll do a little show and tell in my apartment and then give them the pricing that I got from our supplier.
The house that I'm talking about, probably windows aren't the limiting factor because they're
Fair.
really small.
Okay.
They're probably a 10% window to wall ratio.
Already double glazed, already probably PVC?
No, they're aluminium.
Okay.
Non-thermally broken.
Oh, really?
Oh, they frost up and they
Interesting.
freeze up.
Okay.
Good
I haven't had
content
that in a
coming
while.
from that, I'm sure. But
Sure.
It's probably air tightness would be the biggest improvement. It's drafty house, even for the 80s.
Sure.
Vinyl
Sure.
siding, building paper,
Sure.
OSB sheathing.
Sure. Sure.
But yeah,
Not
we
super
should see where it
airtight.
goes. Windows probably not gonna make it on the list for a while yet.
Sure.
Or it'll go with the cladding.
Sure.
When the cladding's 35 years old, vinyl siding is probably getting there.
You could possibly leave the windows in place, put external insulation, and extend the external insulation over the frames to kind of insulate them from the outside.
We've looked
Seen
at
those
trying
before?
to
Yeah.
we've looked at trying to do it. Yeah, we'll see where we get to. But
Yeah.
no plans right now.
That's fair. That's fair.
But yeah, sliding windows pretty drafty.
Is it so my apartment that I was talking about had like double sliders, so you have an external single glazed and an internal single glazed slider. Is that how
no.
yours are? No.
One's fixed, one slides.
I see. Mine was probably because it was a high rise building. It had those from the 90s.
But these are tiny windows.
Sure. True.
10%.
Interesting.
Probably replace the sliding doors first, actually, because they're heavy and old,
true.
worn out. Like,
And those, when those freeze up, because my parents' house had an old set that would freeze up and you just can't open it in the winter.
yeah.
Interesting. All right. Well, I mean, I think we've talked a whole bunch about the windows, the materials. Do we want to talk about detailing really quick?
Detailing and installing them, yeah.
Sure.
I think you ever installed a window? Ever prepped a rough opening?
Have I?
Yeah.
Yes.
Yeah.
A few times.
Yeah. I was helping a contractor with an install. Like, yeah, pass me the tapes and let's get it. It's fun.
Yeah, it's always fun.
Yeah, it's really fun.
It's also fun to get the street cred when you do a job for an installer. And they're like, "Oh, you know how to do that? You're an engineer. Why do you know how to do that?" But
If you're someone who's usually behind a desk, you need to get your hands on some tools and some tapes and some flashings and go and try to do some stuff.
yes,
And do it in your own
Yes.
garage so nobody knows about it.
Yes.
But you need to understand what it takes to install something. When I draw that dashed line on a page, you have to realize that the dashed line doesn't fold the way I think it folds. And
there are physical materials that have
Yes.
physical limitations that you have to work through.
yes, and if you've never played with them or installed them or understand how they work,
Yeah.
how thick they are.
Sure.
Like a common one is a two-ply torch-on bitumen membrane with a cap sheet
Going into opening.
a rough opening of a sliding door.
Sure,
or deck.
sure.
That's
Yeah.
got thickness to it. And
Especially in the corners where you have folds and stuff.
it's not flat. It's bumpy as.
Yep.
So have a think about what that's actually going to look like when you install it. Build in more tolerance.
Correct. More tolerance, a bigger gap. What I've found when I'm doing reviews, especially on window details and sliding door details and things like that, is sometimes there's a sealant joint for an air seal and it's hidden behind an angle or behind something so that there's not really any easy way for someone to get a nozzle in there to install it. So like, let's say you have your sliding door, this is where the top of the frame is, and you'd have to put a sealant joint in there, but your floor surface has like an angle there, and you want the sealant to be there, it can't be there. So you have to move it to up here, let's say. Maybe you're using a tape instead of a sealant. Sometimes I've found where you have either tapes or self-adhered membranes, they go around a certain thing, and then the side where the adhesive is switches.
Oh yeah.
So it's like instead of being wrapped and stuck to this side, it's wrapped and stuck to that side. And so those are a lot of the corrections that I have to do. But if you are with a roll of tape, a sealant gun, something like that, trying things out, you'll be able to notice what's doable and not doable and kind of, I guess, correct yourself when you're doing your detailing.
Yeah, even just having some of those materials in the office. I know a lot of architects will have like pretty things in the office.
Samples, colors.
Samples, like the samples and cladding stuff doesn't do any of the heavy lifting. All the heavy lifting is your wraps and tapes.
Yep.
So like that's all we look at.
Honestly, and sometimes the guys on site when we're doing construction monitoring get surprised by that because they're worrying about this flashing and a saddle and how does it all fit together and this and that. But in design, we've already designed a full, weather tight, water tight membrane behind everything. It's all sealed. It's all nice and detailed. And the flashings and claddings are really just for protection and to deflect most of the water.
They're just to look pretty.
They're there to look pretty. Exactly. Yeah.
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 And create that pressure equalization that we talked about.
Yeah, exactly.
Keep the water off of the wrap layer.
Yeah. Doing the heavy lifting, that's all I care about, and everything else is just aesthetic. Those two windows, I'd say the thing that I look at when I'm on site the most is the sill detailing. Is the sill detailed properly? Because that's where all the water goes down. It's going to settle there, nice and watertight, good upturns, one continuous piece. You're generally good to go from there. One tip that I still have not gotten on any of my projects is rough opening sizes on the drawings. That is typical in Canada. Anytime we would have a window schedule or anything like that, it would show the rough opening sizes, what size the framer has to frame it out to.
Well, we've had standardized rough opening sizes for a long time in Canada.
Oh, that's the next step. That's standardized? Sure, yeah. But I'm talking
No,
even
but
just...
you look at any old picture, any old set of drawings,
Yeah.
and you'll have 4050 windows called out.
4050.
4 foot by 5 foot.
Oh,
Or
interesting.
4656.
I had never
Yes.
put that together. But yeah, fair. Okay.
Yeah, you'll see a lot of that on old, and now that's a raw dimension, not necessarily exactly what the rough opening dimension is.
Sure.
But at least there's been some acknowledgement of ordering windows in some sort of standardized.
In Canada, you can go to Home Depot, which is the equivalent of Bunnings, and buy a window off the shelf, right?
Yeah. Yeah.
Like the standard size window that would fit into most openings in most, group builder kind of houses, I'd say.
Yeah, I think there's a market in New Zealand for that, to be honest. If you
Yeah.
look at someone who manufactures windows in one part of their conglomerate and sells it in another part, you could probably standardize the window market pretty quickly and sell windows off the shelf. And
Would probably take it on.
yeah, it might take a while for that standardization to catch on, but
Yeah.
all things being equal, if you're building an extension to your house and you're going to pick a size of window, you'd probably pick one that you could get tomorrow off the shelf.
Yep.
Than a custom sized one.
Yeah, especially if you don't have to indent it, you don't have to wait for it to be manufactured. Also, as a manufacturer, you can save money and reduce offcuts by just standardizing the lengths of your extrusions and then cutting them in a more efficient way.
A lot of that a lot of manufacturing is so automated that it doesn't make a difference.
Okay,
That's what
fair.
they've told me.
Okay, I see.
Because it's being essentially punched into spreadsheets and being kicked out to robots cutting.
Okay, fair. Well, maybe more on the convenience for homeowners kind of side is where it kind of starts to stack up.
Yeah, availability.
Interesting. So standardization, that's a big key thing, but also just putting the rough opening size on a window schedule for me would speed things up on site. Because if the contractor, like the main contractor or the carpenter or whoever's setting up the framing, is responsible for a certain size and they pay the money to fix it if it's not, then you don't have to have the window manufacturer coming in, measuring it after it's been built and after the membrane goes in, and then manufacturing it, then coming to site and putting it all in. You can kind of start to speed things up because there's a level of trust that people can work on with each other because they know what their responsibility is.
Yeah, you're not wrong there. Yeah.
Have you gotten that on any sites yet? Any projects
we're
yet?
doing a project right now that is precast panels with the windows installed ahead of time.
Okay, cool.
So they better be
the right size.
the right size.
Fair.
Precast pretty tightly controlled
Yeah,
tolerances, so I think it'll
usually.
work fine.
Yeah.
Interesting enough, sequencing of panels to sequencing of windows is the biggest challenge on that project.
What do you mean?
The windows and panels, like they might be stacked in reverse order from each other. So actually making sure that the panel you pour matches up with the window in the truck.
Oh, I see.
So it's like coordinating, make sure you're not like trying to get a window from the back of the container to
Try
go into
putting
that
it over.
hole.
That's
So
interesting logistics to deal with.
yeah,
And I mean, that is kind of the name of the game when you're trying something a little bit new or a little bit different. There's going to be a little bit of a learning curve. There's going to be a little bit of grinding. But once you do it that first time, it just becomes a lot easier the next time, and you know what to avoid. Any last thoughts about Windows? Any last little things?
that is a very surface level touch on Windows. There is
Very much so.
a whole world of Windows, which I think we'll dive into more in future episodes with other experts as well. If you are a window expert,
Supplier,
self-proclaimed
manufacturer,
or otherwise,
designer, tester.
yeah, I'd love to know a little bit more about what world you work in, and especially if you've done like investigations and failures. That stuff's really cool. If you can share some of that information, or where you've seen things go wrong,
Yeah.
or where you see things going in the future. All those things would be great to talk about.
Because we have our own ideas, but, 2 engineers, 3 opinions, and I assume there's a lot more opinions based on different experiences, especially if you're looking at it from supply or from install or from, architectural aesthetics and stuff like that. Everyone's looking at it from a different lens, and we only see what we see. So let's have more of a conversation and see if we can speed things up, make things a little bit more efficient, make things easier to install, and then that'll give us more durability and robustness.
Yeah, it's the name of the game.
Cool. Awesome. Well, thanks for listening, and let us know if you have any window detailing that you need.